have joined. Okay, so good morning everyone. We will start with discussion of homework. Okay, so just tell me before starting this discussion session, how many of you attempted the problems? Tell me, because from this chapter onwards, okay, the module is good. It is not that difficult. You can solve module and HCM both. Okay, right? So how many of you have actually gone through the problems? Just raise your hand first. I'm seeing very few hands. Because see, if you have gone through the problems, then you can understand the concepts, right? What you couldn't understand in the problem, right? Where you did mistakes and all those things. Otherwise, it will be pointless. Okay. Yes, both 9.1, 9.2 and TPP. We will discuss everything. Okay. Got it? Okay. Now 9.1, I hope that all of you have solved this point 1, point 2, like question number 1, question number 2, tell me. Yes or no? Tell me guys. Question number 1, question number 2, their formula putting getting, yes or no? Think about it. Okay, very good. So I need not to discuss question 1 and question number 2. If you have doubt, you can ask, right? But I think that question number 1, question number 2, you can discuss. Okay. Now question number 3. Question number 3 was in test as well as it was in Kahoot session. Yes or no? I hope all of you remember. It was in Kahoot session also. Yes. So question number 3 was also easy. Okay. Very good. Now, when you talk about question number 4, don't you think that question number 4 is basic formula that we have already discussed? Yes. Tell me. Question number 4 is basic formula that we have already discussed. Right? Spring constant, the relation of spring constant with stress strain, right? So we equated the force, है ना? Equate the force is equal to kx and the force is equal to x by L into ya. Got it? Right? So k is equal to the remaining term. That's the easy answer. Okay? Now, see, 1, 2, 3, 4 was so easy. Now, question of 5. Again, question of 5 is also in theory, right? Can anyone tell me the answer of question of 5? Suhas, have you solved question of 5? Tulip, Vivek have solved? Vivek, can you tell me? Message, can you tell me? Question number 5? Who can tell me question number 5? That's basic theory. Siddharth, your audio is not connected. Okay, I'll ask someone. Okay, I'll ask Srihari, I'll ask you. I'm unmuting you. Tell me question number 5. Okay, Srihari, can you speak? Srihari, can you speak?
Hello, sir.
Yeah, question number 5. So we have question number 5. I hope all of you understood this question number 5. So we have first one. Okay, the student plot a graph as shown. From his reading, he needs to determine young modulus of a metal wire but forgot to label the axis, right? The quantities on x and y may be respectively. Okay, now this is quite easy. Tell me. Tell me everyone. It is multiple choices, star marked, so multiple choice. So A, weight hanged and increase in length. So basically weight hanged is force and increase in length is delta L. So is it correct? Very good, Ronak, very good, Koshi. So you guys are saying A is correct. Okay, right? Because F is directly proportional to L. We already know that. Okay, next, stress applied and strain developed. Stress applied and strain, right? So this also we know that, right? This also we know that stress, yes, is directly proportional to strain. This is also correct, right? Okay, sorry, stress strain C1. Stress is directly proportional to del change in length. This is also correct. Length increased and weight hanged. Now last one, D1, right? D is also correct. Now first and A and D both are correct, right? So can you see that all the four are correct? All the four are correct. Yes, right everyone. Now, do you think that this was difficult problem? No, right? Yes. Now, question number 6, everyone. Now, how many of you remember we have already solved question number 6? Tell me. We have already solved question number 6. It was in HC Vama, right? We have discussed this in last class. Okay, sorry, but it was in IC. Yeah. I thought it was in HC Vama. Right, same. The only thing is the data has been changed. Otherwise, everything is same, right? It was easy. So we have already solved this one. Yeah, question 5 IC, right? So this is same as question 5 IC. Now, when you talk about question number 7, question number 7. Let's see question number 7, everyone. Right? Everyone, let's see question number 7. Okay. So I hope all of you have gone through the problem, but still I'll repeat. Two wires have a diameter ratio this. So D1 by D2 is given. D1 is to D2 is given as 1 is to 2. Okay. Means area ratio you can find. Area ratio A1 by A2 is equal to 1 by 4. Right? Got it? Length ratio is given. L1 by L2. L1 is to L2 is equal to 3 by 4. Okay. And Y ratio, Y1 by Y2 is equal to 1 divided by or 2 divided by 3. 2 by 3. Calculate the ratio of elongation produced in the wire. So you have to find delta L1 by delta L2. Don't you think that this is formula putting getting problem? Tell me, don't you think that this is formula putting getting problem? Right? Yes or no? Yes or no, everyone? Because length, ratio, everything is given. So I can say that F by A is equal to Y delta L by L, right? F by A is equal to Y delta L by L. Got it? Now, the only thing that we have to know here is, right? So F is mg, F is mg. Yes or no? And according to this problem, it is given that, okay, two wires of diameter this and this, same stretching force, means force is same. Okay, force is given as same. So I can say that delta L1 is equal to F L1 by A1 into Y1, and delta L2 is equal to F L2 by, tell me, A2 into Y2. Ratio, take the ratio, you will get the answer. Yes or no? Tell me, guys. Tell me yes or no. Easy. Okay. Okay, very good. Now, next one. See, we have solved till question number 7. And if you have solved, right, I hope all of you found these questions, right, not that difficult. Okay. Now, question number 8. Let's see question number 8, everyone. Just go through question number 8. So, aluminium wire and steel wire of the same length. Okay, don't you think that we have actually kind of solved question number 8 in HC Verma, right? Not solved, but this was there in kind of HC Verma. Let's see. Aluminium wire and steel wire of same length and same cross section are joined end to end. Okay. I guess this was in question number, yes, yes, Abhiram. Okay. The composite wires hang from rigid support, right? And load is suspended at free end. Now we have already studied, if you remember, we have already studied that we can take rod as your spring. Yes or no? Tell me guys, yes or no? Think about it, right? And you can take it as series and parallel. I hope all of you remember this concept. Yes or no? Tell me, yes or no? Okay, now let's see how to solve this, right? What are the questions that is asked? We can solve in multiple methods, doesn't matter. Okay, the aluminum rod and steel, same length given, and same cross section are joined end to end. So it's like this. Okay, like this. So if you remember, we have solved a problem like this in example that we had solved, right? We have three segments and you have to find delta L total, which is delta L of this plus delta L of this, right? That's one method. Or you can just take all of them, right, in series and calculate K and then find delta L, right? Okay. Now let's see, the composite wires hang from rigid support suspended at the free end. If increase in length of the composite wire is 2.5 mm. Okay, so total delta L total is given as 2.5, 2.7, sorry, right? You can find delta L of individual. So we know that, tell me, right, what we already know in this problem. Think about it. Suppose this increased as L1, delta L1, and this increases delta L2. So actually we have delta L1 plus delta L2 is equal to this delta L total? Yes or no? Tell me. What we already know, what is given. Okay. Right. Now, what else we know? We know that L1 is equal to L2. L1 is equal to L2, which is given. Okay. Because it is given as same length and cross section area. Okay. So A1 is equal to A2. It is also given. Right. Okay. Now, what is, tell me, what is the length LA in terms of this L1, L2, A1, A2? Can you calculate LA, LB? So we have formula. What formula? F by A is equal to Y delta L by L. From this, we can say that delta L is equal to F into L by AY. Right, everyone? Right? So delta L1, so delta L1 by delta L2, okay, we will get from this equation. Okay, yes or no? Tell me, yes or no? Because force, length, A, everything is same. So it is just Y2 by Y1. Y2 by Y1. Yes or no? Tell me guys. Think about it. Yes or no? Okay, so from this equation, I hope all of you understood now, right? Suppose delta L1 is X. Okay, Y2 by Y1 is how much? 10 power 10, 10 power 11, right? So it is 10. Okay, yes or no? 10. So I can say that delta L1 is steel. So it is steel, right? Delta L of aluminium by delta L of steel, right, is equal to Y of steel, right, by Y of aluminium. So it is 10. Okay, so delta L of aluminium is equal to 10 into delta L of steel. Suppose it is X. So it is 10x plus X is equal to 2.7. So you can get X and 10x easy. Got it? Right? Yes or no? Tell me. Tell me everyone. Yes or no? Easy? Okay. Now next. And we have solved a problem like this in our example. While we were discussing this, we have solved one example like this. I hope all of you remember we have solved a more difficult problem like this, right? We have 3 rods, and that also we have different length and different area. So delta L1, delta L2, and this was total delta L. I hope all of you remember this question, right? It is in the sheet that I have already uploaded. Now, question number 9. Go through question number 9, everyone. Think about it, question number 9. A wire has density of 9 gram per centimeter cube. So density given, okay? Density given. And breaking stress of this. So breaking stress is given, right? So stress is given. So breaking stress means maximum elongation, yes or no? That's the concept that we have already studied. Breaking stress, right, will give me longest maximum elongation. Yes or no? So this is sigma given. And the diameter of wire is 1 mm. So area is given. Area is given. Okay, right? What is the length of wire such that it breaks under its weight when suspended vertically? Okay, so this is your breaking strength, right? This is your breaking strength. Now, can you solve this? Tell me, can you solve this? Tell me. I'm saying that it will break under its weight. So force, right? The force that we will be calculating from this is your breaking force, yes or no? And what is force? Force is mg. Agree? Tell me, right? And we have sigma, which is force by area. So force by area is mg by area. Yes or no? And we know that mass is density into volume, which is area into length into g by area. Area cancelled, right? So this is already we know sigma is equal to rho Lg. Anyone have any issue in this? Tell me, anyone have any issue in this? Guys, if you understood this, just raise your hand. Clear? Now, don't you think that everything is given? Right? Sigma is given, rho is given, G we all know, you have to find L. As simple as that. Yes or no? Tell me, yes or no? Easy? Okay. This is question number 9. Was that very difficult? Think about it, guys. Okay. Ask yourself, right? What is this problem, right? How we can approach, what is the which we couldn't understand. Okay. Now, question number 9. Let's see question number 9. Sorry, 9 we have solved. Sorry. Question number 10. So two similar wires under same load yield elongation of this and this respectively. The area of cross section is given. The area of cross section of second wire is. Now, similar wire. So young modulus is same, yes or no? Tell me. As simple as that. Similar wire means young modulus same. So you have to equate young modulus. Okay. So we know that y is equal to stress by strain, which is F into L by A into delta L. A into delta L. Right, everyone? So I can just equate, I can just equate these two. Same load means F same, okay, right? Delta L given, right? Length also same, similar wires. So I can just calculate it, FL by A1 into delta L1 is equal to, delta L1 is equal to FL by A2 into delta L2, right? So easy, A1 by A2 is equal to delta L2 by delta L1, right? Formula putting getting. Got it, everyone? Tell me, got it? Okay. Any issue in point 1? Think about it, right? Point 1. Do you think that point was very difficult, or it's something which you couldn't solve? Level 3 we'll discuss in that advanced class, Abhiram, okay? Or I'll take one class for discussing level 3, okay, right? Somewhere in the night if you guys are free, okay? Okay, sorry, yeah. So I'll just, yeah, so I'm just covering this. So I can say that, right, when you twist, what actually happens is, right, this point is basically shifting. Yes or no? Tell me, yes or no, right? And overall, every point is shifting to some angle, right? Because when we talk about this torsion, right, it is torque. It is basically torque, okay, right? So it is shifting to a specific angle, right? Got it? Now, let's recall our concept of stress and strain. We know that stress was, when you talk about normal stress or shear stress, it was the change in this position. Yes or no? It was this, right? It was this, right? By this. Okay. Now, in this case, what do you think? The torsion should depend on what? Tell me. Just consider the factors, right? First of all, we'll consider the factors. Okay. So shear stress in this case is called as torsion, as simple as that, right? Shear stress when torque is applied is called as torsion, okay, right? Or torsional stress. It's same thing. Got it, right? And this is your torsional force. So I can say that, okay, right? When you talk about this shear stress, okay, right? So shear stress in case of torsion is termed as T, and theta is again your theta is fixed, right? Theta is your, tell me what was theta? Theta was shear strain, yes or no? Tell me, right? So can I say that we know that shear stress is directly proportional to shear strain. Okay, that we already studied, that we already know. Okay, so can I use the same thing here? Can I say that, okay, torsional stress is also directly proportional to shear strain? Think about it, yes or no? Got it? Anyone have any issue in this? Anyone have any issue in this? Think about it. And then we have some other constant depending on your structure of the rotating wire or any substance. Got it? Tell me. Right? So I can just go through the derivation, but I won't be going to derivation in this class. Those who want to know the derivation of this, because I will be using the concept of torque also. Okay, right? So for now, we just use this formula, right? Need students, you just need to remember this formula. Okay, those who wants to know the derivation, you can either watch the video of advanced class that I'll be taking in this week, okay, or you can attend that, okay, right? I'll be teaching some of the concepts which will be used in solving of advanced problems in that class, okay? Because when you talk about the derivation, it will include torque also, will balance the torque, and then because when you talk about force, right, this is torque now, right? So that's why we have to use those concepts. I'm not going to take time, okay, or so that's why we'll be just focusing on this formula. The formula is this, right? This is not torque, this is basically a torsional strain, which is half pi n is your modulus of rigidity r to the power 4 by L into theta. Got it? That's it, right? Bulking also in advanced class, Abhiram, okay, because basically bulking we have to study in the thermodynamics, right? In this case, everything will be studied in this class, okay, advanced class, right? So for us, even the torr join, this is the formula that we have to use, and we just have to understand that it is directly proportional to theta only. Okay, right? Got it? Tell me. So you just have to remember half pi r to the power 4 n by L. Okay, into theta. So this is your formula for restoring torque, right? This is the formula for restoring torque. Okay, because when you talk about stress, it is what? It is when you talk about stress, if you see the dimensional formula, right? I'll just give you a hint how to derive this. When you talk about stress, it is basically F by area is equal to, because there is no other formula, right? But since it is varying, we will have to N into theta. Yes or no? This is the formula. Tell me. Tell me, guys. This is the formula, right? Sorry, theta. Now here force is written in terms of torque, area is pi r square, which here will become pi r to the power 4 because of some other factors in this. Okay, right? So we will discuss the derivation in advanced class, but I hope all of you understood the basic idea. Okay, so this is your restoring torque. Restoring torque is this. Okay, next. Guys, try to mute yourself, everyone. Okay, homework question number 1 and 2, easy. Have you solved question number 1 and 2? Guys, tell me. Okay, it was formula putting getting. Now question number 3. Question number 3 also I hope all of you can solve, because this is one problem that we have already discussed. Delta V by V is given, bulk model is given, pressure, formula putting getting. Question number 4, right? Again, work done, which is energy, which is half into stress into strain, formula putting getting, right? Okay, into area, sorry, volume. Half into stress into strain into volume, because you are just asked to find work done, not energy density. Okay. Now, fifth one, length given, mg given, area given, mg, length, right? Again, delta L given, right? I hope all of you can find what? Work done, yes or no? Half into stress into strain, into volume, formula putting getting. Question number 5, formula putting getting. Question number 6, force given. Okay, this is force to break the material. Okay, the density of material given. Now, don't you think question number 6 is same? Tell me, question number 6 is same that we just did? Yes or no? Right? Yes? Okay? Okay. Now, 1 to 6 was, see, 1 to 6, how easy this was. Now, question number 7. Let's see question number 7. Now, question number 7 is Searle's experiment. I hope all of you watched the videos of Searle's experiment. Yes or no? Tell me. Yes or no, everyone? Right? So basically, this is nothing. We have only two rods, right, of same length. In one rod, we have mass, right, which is elongated under the action of this mass, and second rod is normal, right? This will be elongated because of temperature, so we will just reduce the elongation of this rod with this one. We will get the actual elongation, then we can find y. Okay, that was the Searle's experiment. Okay, now what is being asked? Tell me, what is being asked? Think about it. Diameter given, okay, length given, okay, extension is also given. Find the maximum possible area in the value of, okay, delta y you are asked to find. Yes or no? Tell me. Yes or no? So I hope all of you have studied error and measurement. because this is something that we have already studied while class. So what's the formula of y? Tell me, what's the formula of y? Y is equal to, tell me, stress by strain, so F by A into delta L by L, right? Yes or no? Right? Think about it. Or in terms of radius, F L by pi r squared into delta L. And using the concept of error and measurement, can you say that, okay, delta y by y is equal to what? Tell me. Delta F by F plus delta L by L plus, tell me, 2 into delta R by R. Yes or no? Tell me guys, yes or no? Right? Plus delta L by L, small l, change in small l, right? Okay, now since force will not change, so it is 0. Okay, force will not change, so it is 0, right? And this is delta capital L by L, and this is delta small l by L, which is the change in elongation, not error in elongation. This is error in length and this is error in elongation, right? So I hope all of you can find y from this equation. Tell me guys, yes or no, right? Y you can find using this directly, formula putting getting, then delta y using this, because you are given this least count, guys. You are given delta L, you are given L, so you can find this ratio. Yes or no? Tell me guys, what is the change, right? What is the least count in length? 0.1. So I'll just calculate delta y by y, which you have to calculate from this, is equal to delta L, least count is 0.1 by L, which is 110, right? So 110 plus 2 delta R by R or 2 delta D by D, doesn't matter, 2 will get cancelled, right? Okay, diameter is equal to 2 into radius, so 2 will get cancelled, so it doesn't matter. Or you can just write in terms of diameter or in terms of radius. Okay, it doesn't matter at all. Now we know that for diameter, okay, the least count is 0.001, so into 0.001 by total diameter is 0.05. Okay, right? Plus elongation you are given, right? 0.00, okay, 0.007, right? 0.007 by 0.125. So I hope all of you can calculate now, right? Yes or no? Okay, that is the formula. I hope all of you understood this one. Tell me guys, raise your hand if you understood this one. Okay, very good. Now question number 8. Question number 8. Don't you think that question number 8 is formula putting getting, right? So we know that what? Torque, restoring torque. It is just from that we just saw, half pi r to power 4 n by L theta. Now, what is the formula of force in terms of torque? Tell me. What's the formula of torque in terms of force? We know that torque is equal to R cross F. So if it's 90 degrees, so I'll just write as FR or F cross R. I'll just write FR. Okay, got it? Now FR is equal to this. Tell me. Now everything is given. Can you find theta? Tell me. Everything is given. This is formula putting getting. Can you find theta? Just put the value, get the answer. Yes. That's why when you talk about NEET and JEE mains, you are just asked to find the basic formula. Ninth one basic formula, yes or no? Ninth one basic formula. We have already studied this. I hope all of you remember, right? That this is this energy density per unit volume is half into Y into strain square. Okay, question number 10. Now, when you see question number 10, right? When a load of on Y is increased slowly from 3 to 5, the elongation is this from this. How much work done is, okay, now tell me how much work done? You have to find the change in work done. Yes or no? Change in work. Yes or no, guys? Tell me. Yes or no? Can you solve it? Can you solve it? If you remember, we know that work done is equal to what? Work done is equal to half into stress, which is force by area, into strain, which is delta L by L, into volume, which is A into L. So L get cancelled, A get cancelled. So work done is nothing but half into force into delta L, right? So we actually need force and delta L to calculate work done, right? Tell me, yes or no? Think about it. Yes or no, everyone? So can I say that, okay, W1, right? When force is of 3 kg, right? 3 into 10, and elongation is 0.61, and W2, this weight and this, right? This is mass, you have to multiply G also. Take the difference, you'll get the answer. Okay, everyone? Got it? Sumaya, Tulip, Vivek, Anamika, Ria, getting everything? Samya, Chulika, Priyanka, all of you are getting till now? Okay, very good, Sumaya, very good, Samya. I hope all of you are getting all the concepts till now, till question number 10. Till question number 10, anyone have any issues or any feeling like this question was very difficult? Okay, now question number 11. Question number 11, think about it. Right, question number 11. A boy catapult is made up of rubber cord, okay, 42 centimeter long, length given. Write down the information, okay. Diameter given, means area we know. Delta L, stretch the cord, delta L given. Find the young modulus. If a stone weighing this, mass is also given. Catapult velocity 20 meter per second. Okay, this is velocity. So kinetic energy is given. So I hope by reading the problem, we know that this is a problem of work energy theorem. Yes or no? Tell me. Yes or no? Right? And we know that this work done by the elastic force, right? This should be equal to changing kinetic energy. Got it? Which is half mv square. Okay, so half mv square should be equal to half into force into elongation, delta L. Any issues? Any issues? Think about it. Tell me, guys, any issue in this? Can you solve it? Because this you already know, right? Delta L you know. Can you find force? Half of will get cancelled, right? Force is equal to what? mv square by delta L, right? Then stress is force per unit area, which is mv square by A into delta L. I hope all of you can calculate this now. Tell me. Easy. Question 11, everyone. Right? Then strain also you can calculate. Strain also you can calculate. And young modulus is stress by strain. Yes? Got it? Right? Or, okay, or you can just use half into y into strain square. Strain square. Right? From here you can get directly. Yes or no? Tell me. Yes or no? Think about it. The only difference is this is for work done per unit volume. So you have to multiply by area into length also. Okay. Next, question number 12. Question number 11, everyone understood? Just raise your hand. Everyone got this? Question number 11. Okay, very good, everyone. Now question number 12. Preetham, are you getting? Anga, Anjali? Preetham is absent today, I guess. Okay, question number 12. What will be the density of lead under the pressure of this? Okay, I hope all of you understood. I hope all of you remember the formula of bulk modulus. Yes or no? Tell me. Tell me yes. And I hope all of you remember the formula, right? Delta V or by V is nothing but delta D by D. Yes or no? We have solved a problem like this, right? Relation of bulk modulus with density, right, Abhiram? Tell me, right? What was the formula? Pressure is equal to bulk modulus delta V by V. And this can also be written as pressure is equal to bulk modulus into delta D by D, which is the density. Yes. Now, if you use this formula, or I'll just write as delta P, right? And this is delta D by D, where this is your density, right? Or delta rho by rho. Now, what is delta rho? Think about it. Think about it, everyone. So I'll just, instead of going through, I'll just, yes, Aviram, very good, right? So that's the derived formula, right? I'll just derive it. B into what? Tell me. Delta rho by rho. Okay. Now, delta P by B is equal to delta rho by rho. Yes or no? Think about it. Yes or no? Which is delta P by B is equal to, or I'll just write it as rho naught minus over here, right? Rho density. Sorry, this minus will go inside now because change in volume, change in pressure will be negative. Wait, okay. I'll just write it directly. Rho at depth minus rho naught by rho naught. Okay, got it? Tell me, got it? I hope all of you remember that minus delta V by V is equal to rho delta rho by rho, right? So if you use this, I can say that by D and delta P by B. Yes or no, guys? Tell me. The same formula that I used, right? Yes or no? Tell me. You can use directly this formula. Got it? You can just note it down. But again, we derived it from the same formula. Now, I hope all of you still remember that in last class, right, we derived, right, density is equal to mass by volume. Okay. So I hope all of you know that delta rho by rho is equal to minus delta V by V, right? Because if volume will decrease, then density will increase. That's why it is minus. I just substituted this in this equation. Okay, got it, everyone? Okay, next, last question, question number 13. A lift is tied with a thick iron wire and its mass is given. So just write down the information that we already have. Okay, mass is given, means force we know. What should be the minimum diameter of wire if maximum acceleration of the lift is this? Okay, this is the maximum acceleration, right? This maximum acceleration is given. So tension you have to find. Tension you have to find. I hope all of you can use your NLM to find tension. And maximum stress, safe stress is given. Now this question is comparatively easy, yes or no? We know that mg minus, tell me, tension. Now lift is going where? Upside or downside? Down, right? So I'll just say that mg minus t is equal to m minus ma. Okay, sorry, t minus mg, because it's going upward now, then only it will break, right? Downward it's easy. So t minus mg is equal to ma, right? Yes or no? Because it will break only when it is pulling upwards. Yes or no? Tell me, right, everyone? So tension is equal to what? mg plus a, right? And we know that stress is equal to what? Tension by area is equal to stress. Okay, so can you calculate diameter now? Tell me, can you calculate radius or diameter now? Yes or no? Tell me, guys, yes or no? You can calculate, raise your hand. Yes? Okay, very good. So we are done with this. I hope all of you understood this. Okay, next TPP. So we will complete this even if we take extra 15 minutes, it's fine. Okay, we'll complete this. Okay, right? Now, TPP, I'll just, those who have doubt, you can ask. Otherwise, I'll just discuss the important questions because question 1 to 5, it's easy. We have already done it. Question 1 to 5. Anyone have doubt in question 1 to 5? Because all the questions we have already done and they are easy. 1 to 5. Thermal expansion we will leave for now. Okay, Aviram. Thermal expansion we'll leave it for now because we will discuss that in the next chapter. Okay. So I hope there's no doubt between 1 to 5. 6 to 10. Any doubt between 6 to 10? Any doubt between 6 to 10? Anyone? Abhiram, Ovais, Arjan, Meet, Jasharan, Pranjal, Tulip, Vivek, Shrihari, Siddharth, Ronak, Samya, Sania, Nishita. No doubt. Because till question number 10, if you have discussed, if you understood previous year, sorry, this in-class exercise and homework, everything would be easy, right? Question number 9, we just discussed. Question number 10, right? Question number 10, we just discussed. It's the same, half mv square is equal to work done, okay? Now, 11 to 20, 11 to 20. 11 to 20, 16. Anyone have doubt in question number 16? Okay, 16. Now let's see, question number 16. Now, this is the same one that we just did, right? But in this case, when I talk about question number 16, okay, it is given a twist, right? It is given a twist, yes or no? Think about it, right? So what is the, if it is given a twist, so what is the restoring force? Tell me, restoring force is given by 1 by 2 pi r to the power 4 n by L into theta. Agree? Tell me, agree? Yes or no? Right? Now, don't you think that if we talked about longitudinal stress, longitudinal strain, the force was equal in these two. Now, don't you think that if we talk about restoring torque, it will be equal in both the rods? Yes or no? Tell me. Yes or no? And this is actually delta theta, na? This is not absolute theta. This is change in, right? This is change in angle, delta theta. Okay? Right? Now, if torque is equal, can you calculate? So I can say that if torque is equal, I'll just relate these two. I'll just relate these two. So what we have? pi r1 to the power 4, okay, right, into n because they're made up of same material, so n delta theta 1 by 2 L1 is equal to, I'll just rub this one, pi r2 to the power 4 n delta theta 2 by 2L2. Right, everyone? Tell me. So we have given what? R1, R2, L1, L2 ratio we have given, NN will get cancelled. Got it? Tell me, got it? Yes or no? Yes or no? Now, think about it. What is the change in theta? Right? What is change in theta for each one? When you talk about this one, this small rod, right? It is given that, okay, initially it was as theta dash. Initially, it was at theta dash. And now it is at theta naught. So what is the difference? Tell me, what is the difference? It will be theta naught minus theta dash. Yes or no? Yes or no? This end is at theta naught and this is at theta, sorry, theta dash. This is at theta naught. So total change is theta naught minus theta dash. Agree? So this is your, this delta theta. And for this end is at theta naught and this end is at theta. So what's the difference? It is theta minus theta naught. Anyone have any issues? Tell me, anyone have any issue in this? Because theta is the change in angle between two ends now, right? Okay, right? So just put it, right? Let's put it. So I'll just put R1, I'll just assume at this one. This is R1, this is R2 or L1, L2. So it is given that what is the change in R? R is half. So R1 is half of R2. So pi will get cancelled. So R by 2 to the power 4 divided by length is also half. Length is also half, na? Length is also half. So 2 into L by 2. 2 will also get cancelled. So L by 2. Okay, into this change, which is theta naught minus theta dash is equal to, this is r to the power 4 by L to the power 4 L into theta minus theta naught, right? So I hope all of you can solve it now. Okay, sorry, right? If you solve it, what we will get? Tell me, what we will get? R to the power 4, R to the power 4 will get cancelled, L will get cancelled. So we will have 2Q. So it is theta naught minus theta dash by 8 is equal to theta minus theta naught. So this will go this side. Okay. So I can calculate this. Yes or no? Because if I'm considering this as 0, consider this as 0, right? Okay, because if it is rigid, consider this as 0. Then theta naught you can calculate, theta naught. Yes or no? Tell me, what is theta naught? This will go this side. If I consider this as 0, this will go this side, right? So it will be 8 by 9 theta. That's the answer. D. Everyone got this? Tell me, everyone got this? Yes or no? This was a good question, but everyone got this? Okay, very good, Samya. Next, till question number 30. Till question number 30. Anyone have any doubt in question number 20? No? Okay, till question number 30, everyone. I don't think that you will have any doubt till question number 30. You can solve every question till question number 30 because it is formula putting getting. Okay, right? Question number 26 is use of this question number 26 Okay, will be use of bit of mechanics because tension, right? In this case, tension component we will take here, here. The only thing is the component of tension, right? 27 also you can solve. Formula putting getting 28 also you can solve. Formula putting getting 29 also you can solve. Formula putting getting 30 also formula putting getting 32 also formula putting getting. TP is quite easy of this, okay? TP and JE means previous year or NEET previous year will be quite easy, okay? So the order that you should follow is after module, TPP, then JE previous I've already told you, and NEET previous year, right? This is compulsory. Then go for any other materials, okay? And I've uploaded the material also, you can use that also. So any doubt till question number 30? No, 35? Any doubt till question number 35? No? Any doubt till question number 40, everyone? Any doubt till question number 40? Question number 38? Pranjal, Abhiram, Srihari? Okay, no doubt. Till question number 40, guys. Question number 40. Everyone go through question number 40. Everyone go through question number 40. Yes, Abhiram, I'll cover that. Okay. That is just the relationship between these three parameters, mu, y, and b. Okay. Question number 40. Everyone go through question 40. I hope all of you read the problem, guys. Okay, now let's solve. A steel wire of length 2 meter, length is given as 2 meter, radius is given as 1 meter, y is given, and 1 kg of sphere is attached to the end of the wire. Think about it. Why this question is, I told you to solve this question, because if you remember, right, we have done a problem in which, right, when rod is rotated, right, a rod is rotated, okay, and you have to find the stress or elongation. Yes or no? Tell me. Yes or no? Right? Now this problem is based on that only. Okay, this problem is based on that only. Now think about it. What is given? Omega is given. Okay, you have to find the elongation of wire, delta L. Can you do this? Tell me, can you do this? Think about it, everyone. The only thing that will change is tension, na? Tell me, the only thing which change will tension, right? Now, when you talk about tension, suppose it is rotated, okay, with one end of the wire and rotated in vertical circle, means it is rotated like this. Got it? Now, when it is at lowest point, think about it. When it is at lowest point, it's rotated. And when it is at lowest point, what are the forces that are acting on this object? Tell me. There's mg, right? And there's one centrifugal force. Yes or no? Tell me. Yes or no? Centrifugal force is m omega square r. Okay. Not minus OS plus. Okay, because centrifugal force in downward direction, right? And tension will be equal to this force. So I can say that this restoring force, which was tension, is mg plus m omega square. Now r is this length, L, right? Got it? Omega is given. Okay, V is not given, omega is given, right? Yes or no? Yes or no? Right? That's the only difference. That's the only thing that you have to worry about. Now can you find delta L? Right? Delta L is equal to what? Tension into L by A into Y. Got it? Yes or no? Put the values, get the answer, right? Okay. Okay. Now till question number 45. Till question 45. Any doubts? I don't think that you will have any doubt in till question 45. Question 46. Everyone, just go through question 46. Just go through question 46. Okay, so I hope all of you have gone through question 46. Let's see what happens in question 46. Two wires of same material, young modulus given, same length, but radii r and 2r, okay, are respectively joined. Now, don't think that this problem is right. When talk about this problem, we all know what is in this problem. You have to find what? Elastic potential energy. Now, can you calculate elastic potential energy of this whole system? Don't you think that it will be elastic potential energy of this plus elastic potential energy of this? Tell me. Yes or no? Think about it. Because when you talk about spring, okay, we talk about spring, we add it, right? So in this case also, it will be the elastic potential energy of this plus elastic potential energy of this. Okay. Now, we know this, right? Let's see what we know. Let's see what we know, right? Length same, radius different. So what we already know, force is equal to what? Tell me. Force is equal to area into y, okay, into x, which is elongation, by L, which is length. Yes. Yes. And when you talk about work done due to first W1 is nothing but half into force into elongation. Anyone have any issue in this? Anyone have any issue in this? So I assume this whole thing has a constant K1, right? So I can write it W1 is equal to half K1 into X or X1 square. X1 square, right? Tell me, yes or no? Yes or no? Yes. And in same way, W2 is equal to half into K2 into X2 square, right everyone? But there's one more thing. When you talk about force, force is this W, yes or no? Wait. So can I say that? Can I say that? Right? Force is equal to, this force is equal to what? Kx, this one, right? K1 x1. So x1 is equal to what? W1, sorry, W by K1. In the same way, x2 is equal to W by K2. Yes or no? Tell me everyone, yes or no? Think about it, yes or no? I'll just do it once again, okay? Force is equal to area into y by L into x, which is your elongation, right? Okay, so for force is equal to, this is K1, I'm just using this constant K1 and this elongation as x1. So from here, x1 is F by K1 and x2 as F by K2, right? Got it? Now, work done is work done due to first wire plus work done due to second wire, which is half, right? K1 into x1 square plus half K2 into x2 square. I hope all of you understood how, because it is F into x, right? Which is half K1 into x1 is what? F by K1, and F is equal to W, W by K1. So it is W by K1 whole square plus half K2, W by K2 whole square. Any issue in this? Tell me, any issue till this point? Any issue till this point? No? Okay. So can I solve it like this? Half W square will get common. We will have 1 by K1 plus 1 by K2. Put this value, now put this value, right? You'll put this value, you will get the answer because A1, L1 is already given. Okay. Got it? Right? Okay. Bye everyone. Sorry. Not bye. My bad. Okay. So yeah, till question number 46 done. Till question for 50. Anyone have any doubt till question 50? I think that you might not be having any doubt till question number 50. Okay, right? Right, everyone? Okay, so we are done with this. Okay, so in next class, in next fifth class, we'll do the previous year. Okay, previous year of, right, gravitation and, okay, I think this chapter is mixed, right? Solids and fluids are mixed in previous year. Yes or no? Okay, for both NEET and JEE. For both NEET and JEE. NEET and JEE. I'll tell you the questions that you have to solve. Don't worry. I'll tell you the questions. Okay, right? I'll tell you the questions which you have to solve in both NEET and JEE. Right? JEE means only. We'll discuss JEE means only and NEET. Okay, got it? Okay. So I hope all of you understood this chapter, right? Okay. Thank you, everyone. Bye, everyone. Bye, everyone. Thank you.